Welcome to True Projects. In this video, we are going to explain the project Obesity Level Estimation based on machine learning methods and ANN, that is artificial neural networks. Before diving into the execution, let me give an overview of the project. So, obesity estimation is very important for managing public health and planning interventions, as excessive body fat accumulation leads to health issues like heart diseases and diabetes. Traditional methods of obesity level estimation, like BMI, that is body mass index, have limitations including inaccuracies in muscle mass assessment, neglect of body composition, and limited adjustment for age and gender differences. So, to enhance the accuracy and reliability of obesity level estimation, advanced techniques like machine learning and artificial neural networks are employed. So ML and ANN can handle large data sets and analyze complex relationships between factors contributing to obesity, leading to improved estimation models. So we will be using machine learning and artificial neural network models for obesity level estimation. Now we'll see the workflow. So the project involves exploration of dataset containing demographics, lifestyle, and health indicators related to obesity levels. So first we will visualize the dataset. So we'll use data visualization techniques to gain insights into data distributions and trends. We'll understand the patterns. After that, we will pre-process the dataset. So data pre-processing involves label encoding, which converts categorical variables into numerical. And we will use support vector machine, that is SVM, for feature selection. After this, we will split the dataset into training and testing for training and evaluating the models. So after this, we will employ machine learning algorithms like naive Bayes, decision trees, random forest, etc. We will train them using the training dataset and evaluate them using metrics like accuracy, precision, recall, and F1 score. We will select the best performing model among all for obesity level estimation. So this is what we will do in this project. So this project benefits include improved health management through accurate prediction models, informed policy planning by understanding obesity levels, and empowerment of individuals by enabling them to make informed decisions about their health and seek appropriate assistance, thereby enhancing their overall well being. So, the overall aim is to create accurate machine learning models to estimate obesity levels. So, it evaluates the effectiveness of different algorithms in predicting obesity levels, provides insights into factors influencing obesity levels, and promotes personalized healthcare by tailoring interventions to individual needs. Now, we'll see the software and hardware requirements to execute this project. So hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application needed is Anaconda, primary language needed is Python, front-end framework required is Flask, back-end framework needed is Jupyter Notebook, database needed is SQLite 3, and front-end technologies required are HTML, CSS, JavaScript, and Bootstrap 4. Now we'll look at the algorithms built. So these are the algorithms proposed by the author in the base paper. For improved performance, we are proposing voting classifier in this project. So we will be building all these models, the models proposed by the author in the base paper and the model which we are proposing, and will compare their performance to select the best performing one. Now we will understand about the algorithm which we have proposed, the voting classifier. So, voting classifier is an ensemble learning technique where multiple individual classifiers, such as bagging classifier with random forest, and decision tree classifier in this project are combined to make a final prediction. During training, these base classifiers learn from the dataset, and during prediction, their outputs are aggregated using a voting mechanism, either soft or hard voting. In soft voting, the predicted probabilities are averaged, while in hard voting, the majority vote determines the final prediction. We are using soft voting in this project. By harnessing the diverse trends of the base classifiers, the voting classifier aims to enhance prediction accuracy. So, this is about the proposed model voting classifier. So, after comparing all these models' performance, we have observed that voting classifier has outperformed all other models in all the performance metrics. So, we have deployed voting classifier into Flask web framework. So, we will be executing the project using Flask web application. Before that, first we need to open the code folder which contains the project source code files. So, this is the code folder and these are the contents I have in the code folder. This is static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And this is model file which contains algorithm information. This file will be loaded into the project code during runtime to utilize the trained models. This is Notebook Jupyter source file which contains a combination of code, graphs, and outputs all in one place. So Jupyter Notebook allows users to write and execute code in individual cells, making it a popular choice for data science. This is Obesity CSV file which contains obesity estimation data. So this dataset contains various attributes including gender, age, height, weight, and lifestyle factors along with the target variable. This is the target variable. So this target variable reflects the individual's obesity level based on the WHO classification system. So the classification system categorizes individuals into different obesity levels such as normal weight, insufficient weight, overweight level 1, overweight level 2, obesity type 2, obesity type 1, obesity type 3. So, by analyzing individual behaviors, lifestyle choices, and the assigned obesity level, that is the target variable, we gain insights into factors influencing obesity. So, machine learning models use this information to predict obesity levels accurately. So, these predictions enable tailored interventions and healthcare strategies, ultimately improving health outcomes. So we will use this dataset to train and evaluate our machine learning and ANN models. I'm closing this dataset and this is sample file in which I have test cases on which we'll make the predictions. This is signup.db file. This file is the database file used to store user information. So now copy the path of the code folder from the address bar of the file explorer. I'm copying it. Open Anaconda prompt. Use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address localhost and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. And here we can see a sign up link, click on it. So if we are new users, we have to register ourselves first, fill in all these details and click on register button to sign up. And if we already have an account, we can directly log in by clicking on this link. So as I'm already a member, I'm clicking on this link. Here we have to give our credentials, username and password. I'm giving mine and click on login button. So it has redirected us to the estimations page. Now we have to fill in these parameters and click on predict button to get the obesity level estimation. First, we'll understand these parameters. The first parameter is gender. It indicates the gender of the individual, male or female. The next one is height. It represents the height of the individual in meters. Family history with overweight indicates whether the individual has a family history of overweight, yes or no. FAVC stands for frequency of consumption of high caloric food and represents how often the individual consumes high caloric food. Yes means yes, he consumes high caloric food. No means he doesn't consume high caloric food. FCVC stands for frequency of consumption of vegetables and represents how often the individual consumes vegetables. NCP stands for number of main meals and denotes the number of main meals consumed by the individual per day. CAEC stands for consumption of alcohol and represents the frequency of alcohol consumption by the individual in the group. Smoke indicates whether the individual smokes, yes or no. CH20 represents the daily water intake of the individual in liters. SCC stands for calories consumption monitoring and indicates whether the individual monitors their calorie consumption, yes or no. FAF stands for physical activity frequency and represents the frequency of physical activity per week. TUE stands for time using technology devices and denotes the time spent using technology devices per day. And CALC stands for consumption of alcohol, and this time it represents the frequency of alcohol consumption by the individual, only individual. Now we'll fill in these parameters. Gender would be female, height would be 1.75 meters. Family history with overweight is yes, she has a family history with overweight. FAVC would be yes, she consumes a lot of high caloric food. FCVC is 2. So FCVC represents how often the individual consumes vegetables. NCP would be 4. That means she consumes 4 main meals a day. CAEC would be frequently. So it represents the frequency of alcohol consumption by the individual in group. Smoke would be no, she doesn't smoke. CH20 would be 2. That means she consumes 2 liters of water a day. SCC is no. So SCC stands for calories consumption monitoring. That means she doesn't monitor her calories consumption. FAF would be 3. So FAF represents the frequency of physical activity per week. TUE would be 2. So TUE stands for time using technology devices. So it denotes the time spent using technology devices per day. And CALC would be no. So CALC stands for consumption of alcohol again, but this time it represents the frequency of alcohol consumption by the individual only. Now click on predict button. So here we can see the outcome, that is the obesity level of the person is overweight level 2. So according to the given set of parameters, the application has classified this person has obesity and the obesity type is overweight level 2. We'll try giving another set of parameters. Click on prediction link. Gender would be female again. Height would be 1.62. Family history with overweight is yes. FAVC is yes. She consumes a lot of high caloric food. FCVC is 3. NCP is 3. CAEC would be sometimes. Smoke is no, she doesn't smoke. CH20 is 3. She consumes 3 liters of water a day. SCC would be no, she doesn't monitor her calories consumption. FAF would be 0. TUE is 1. CALC would be sometimes. Now click on predict button. So here we can see the classification, that is the obesity level of the person is obesity type 3. So this person has obesity and the type is obesity type 3. Click on prediction link. We'll try again. This time gender would be male. Height would be 1.8. Family history with overweight is yes. FAVC is no. FCVC would be 2. NCP is 3. CAEC would be sometimes. Smoke is no, he doesn't smoke. CH20 would be 2 liters a day. SCC is no. FAF would be 1. TUE is 2 and CALC would be sometimes. Now click on predict button. So here we can see this person does not have obesity. So he is of normal weight. Click on prediction link. This time gender would be male again. Height is 2. Family history with overweight is yes. FAVC would be yes. FCVC is 2. NCP is 3. CAEC sometimes. Smoke is no. CH20 would be 2 liters a day. SCC would be no. He doesn't monitor his calories consumption. FAF would be 1. TUE is 1. And CALC would be sometimes. Now click on predict button. Here we can see the obesity level of the person is overweight level 1. He is of overweight level 1 according to the given set of parameters. Click on prediction link. We'll try with some more test cases. So this time gender would be female. Height would be 2. Family history with overweight is no. FAVC is yes. FCVC is 2. NCP is 3. CAEC would be sometimes. Smoke is no. CH20 is 1 liter a day. SCC is no. FAF would be 0. TUE is 0. And CALC would be sometimes. Now click on predict button. Here we can see the obesity level of the person is obesity type 1. Click on prediction link. This time gender would be male, height would be 2. Family history with overweight is yes. FAVC is yes. FCVC would be 2. NCP is 3. CAEC is sometimes. Smoke is no. CH20 is 2. SCC would be no. FF is 2 and TUE is 1. CALC would be sometimes. Click on predict button. So we can see the obesity level of the person is overweight level 1. Click on prediction link. This time gender would be female. Height is 2. Family history with overweight is yes. FAVC is yes. FCVC would be 2. NCP would be 1. CAEC is sometimes. Smoke is no. CH20 is 2. SCC would be no. FAF is 1. TUE is 0 and CALC is no. Now click on predict button. So here we can see the obesity level of the person is normal weight. In the same way, we can give any set of parameters and can get the predictions.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.